neon blue fire ignites the sky of a doomed world. 1 second, the planet breathes under the light of a stable sun. In the next moment, the sky screams as high-energy gamma rays strip away the protective ozone layer, exposing every biological cell to the unfiltered fury of a cosmic furnace. No sirens cry out. No warnings appear in the sky. A silent, invisible wave of radiation travels at the speed of light, carrying the death warrant of an entire biosphere. Within hours, the delicate food chain collapses as radiation destroys the plankton in the shallow seas. Within days, the oceans become graveyards. This world remained perfect, a lush twin of Earth, until the universe decided to reset the biological clock. The destruction of this hypothetical world is not a rare tragedy. Evidence suggests this catastrophe is the standard operating procedure of the cosmos. We look at the stars and wonder why the galaxy remains silent, assuming that life is a biological inevitability that leads to intelligence. But the universe is not a cradle. The universe is a regulation machine. We are not the masters of nature, but the lucky survivors of an indifferent shooting gallery. Our existence on Earth depends on a rare window of stability, a 4 billion-year shield that the rest of the cosmos rarely provides. This silence we hear from the stars is not a lack of life. The silence is the sound of a galaxy periodically resetting. The official story of Fermi's Paradox, the question of why we have found no evidence of aliens despite the high probability of their existence, suggests that civilizations are simply too far away. But research into astrophysical regulation, pioneered by astrophysicists like James Annis and Piran, reveals a darker possibility. We will uncover how 90% of galaxies suffer lethal resets every billion years, turning entire star clusters into dead zones. These hidden layers of cosmic violence connect ancient mass extinctions on Earth to the empty horizons of distant star systems. We have spent decades looking for a galactic community, unaware that we were the only ones who forgot to stay dead. We must ask if the Great Filter is not a biological wall, but a catastrophic matter of timing. Our journey begins as we descend into the history of cosmic violence. We will first confront the lethal flash of the gamma-ray burst, a celestial furnace that sterilizes whole star systems in seconds. Then, we will navigate the thin rings of the galactic habitable zone, mapped by researchers like Charles Lineweaver, to find the only shores where life can safely anchor. We will trace the scars of these resets through the fossil record of Earth and confront the synchronization hypothesis, the terrifying possibility that we all emerge together because the galaxy only recently stopped screaming. The more urgent mystery is not why the universe appears so empty, but why we are still here. Humanity exists because we are statistical survivors of an indifferent universe, fragile observers of a lethal clock. We are the first generation of observers in the history of our galaxy capable of understanding this threat. Will we achieve galactic mitigation and survive the next reset, or will we remain a brief flash in the dark? The choice to transform begins now. The clock is ticking, and the choice is ours. If this kind of investigation is your idea of a good time, consider subscribing so you do not miss the next one. And while you are here, comment where you are watching this from. The theories change, but this curious little community spans the whole planet. 10,000 light-years from the Sun, a world once existed that was the twin of the Earth. This planet orbited a stable, yellow star in a quiet pocket of the galaxy. The world contained oceans of liquid water and an atmosphere rich in oxygen. Complex organisms teemed in the depths of the seas. Forests of emerald vegetation blanketed the continents. No asteroid threatened this world. No tectonic upheaval shook the foundations of the cities. Then, without warning, the sky turned a blue that was too bright to be light. Gamma radiation, born from the collapse of a massive star in a distant nebula, tore through the upper atmosphere at 99.9% of the speed of light. In less than 10 seconds, the ozone layer shattered. The atmosphere turned into a brown, toxic fog of nitrogen dioxide. The radiation turned the surface into a radioactive furnace. Every organism on the continent was erased in a heartbeat. The oceans cooled as the toxic haze blocked the sun. This world did not die because of a local accident. This world was reset by the universe. This story represents the silent reality of the 90% of galaxies, now recognized as dead zones. The galaxy represents a shooting gallery, and we are simply the targets that have not been hit yet. The story of the greatest threat to life in the universe began outside research laboratories and university observatories. The discovery occurred during the high-stakes silence of the Cold War. In 1967, the United States Air Force launched a series of satellites known as the Vela Project. These machines were not designed to map the stars or search for alien civilizations. The primary mission of the Vela satellites was to monitor the Earth for clandestine nuclear tests that might violate the Atmospheric Test Ban Treaty. These satellites carried sensors sensitive to gamma rays, the high-energy light produced by the detonation of an atomic bomb. On July 2, 1967, the sensors on Vela 4 and Vela 3 detected a surge of radiation. The signal was intense, sudden, and entirely unexpected. However, as the researchers at Los Alamos analyzed the data, a puzzling pattern emerged. The flash of gamma rays did not look like a nuclear explosion. A bomb produces a very specific sharp pulse of radiation that fades in a predictable way. This radiation signal was different. The flash flickered. The radiation lasted for several seconds, far longer than any human weapon could sustain. Most importantly, the signal did not come from the direction of the Soviet Union. The data showed that the burst came from deep space. Ray Klebsadel and his colleagues spent years confirming the results, terrified of a false alarm that could trigger a global war. They eventually realized that the universe was producing flashes of energy that made human nuclear weapons look like the flickering of a match in a hurricane. These gamma-ray bursts were the first clue that the galaxy was far more lethal than anyone had dared to imagine. A gamma-ray burst represents the most extreme release of energy ever observed in the cosmos. These events occur when a massive star reaches the end of a long life and collapses into a black hole, or when two neutron stars collide in a violent merger. In either scenario, the core of the star cannot support the weight of the outer layers. The collapse happens in milliseconds, concentrating the mass of an entire sun into a point of infinite density. This collapse triggers the release of 10 to the power of 52 ergs of energy. To understand this magnitude, consider the sun. The sun is a massive, stable furnace that has burned for 4.5 billion years. A single gamma-ray burst releases more energy in 10 seconds than the sun produces during a 10 billion-year lifespan. This energy is not released in a sphere. The physics of the collapse forces the radiation into two extremely narrow jets that blast out from the poles of the dying star. These jets travel at over 99.9% of the speed of light. These beams are effectively cosmic lasers, carrying enough power to sterilize an entire galaxy if the galaxy is small enough. The radiation consists primarily of 300 kilo-electron-volt gamma rays. These photons are so energetic that they do not bounce off matter. These photons rip through atoms, stripping away electrons and breaking molecular bonds. If such a beam strikes a planet, the atmospheric shielding that protects life becomes a liability. The gamma rays ionize the nitrogen and oxygen in the air, creating a thick layer of nitrogen dioxide. This chemical reaction turns the sky into a brown, toxic fog that absorbs the light of the sun and destroys the ozone layer in a matter of hours. Imagine the atmosphere of a planet as a delicate shield, a thin layer of glass protecting a candle from a gale. This glass is the ozone layer. Under normal conditions, the ozone layer filters out the harsh ultraviolet light from the host sun, allowing complex biology to thrive on the surface. Now, imagine a gamma ray burst as a high-powered laser pointed directly at that glass. The problem involves the energy of the laser and the speed at which the energy arrives. Consider a bathtub being filled with water. If the faucet is turned onto a steady drip, the tub fills slowly over hours. The drain can handle the flow, and the water level stays safe. This steady flow is how a sun provides energy to a planet. A gamma-ray burst is equivalent to dumping the entire contents of an Olympic-sized swimming pool into that same bathtub in less than 1 second. The drain cannot cope. The tub overflows with catastrophic force. The force of the water shatters the tub and destroys the house. This shift in energy represents the difference between solar radiation and a cosmic reset. The atmosphere of a planet like Earth is designed to handle the steady drip of the sun. The atmosphere cannot survive the sudden, overwhelming flood of a gamma-ray burst. The nitrogen dioxide produced by the flash does more than block the sun. This nitrogen dioxide triggers a global cooling event, while the loss of ozone allows lethal ultraviolet radiation to reach the ground. Life is effectively trapped between a frozen world and a radioactive furnace. The precise mechanics of how a distant star can kill a planet across thousands of light years remained a mystery until the late 20th century. Researchers like Brian Thomas and Adrian Mellott at the University of Kansas began to model the interaction between gamma radiation and the chemistry of the upper atmosphere. The findings were terrifying. A burst occurring within 6,000 light-years of Earth would cause a global depletion of the ozone layer by 70%. This depletion is not a temporary dip. The models show that the ozone layer would take years to recover. During that time, the surface of the planet would be bombarded by solar ultraviolet radiation at levels that are incompatible with land-based life. Plankton in the upper layers of the ocean would die off within days, triggering a collapse of the entire marine food web. The nitrogen dioxide would also produce acid rain on a global scale, poisoning the soil and the freshwater systems. The absence of advanced civilizations suggests the universe periodically reaches out and breaks the biological shield of every habitable world. The question is not why life is rare, but how life survives long enough to build a radio telescope. The record of the Earth proves the resilience of life, but the history of the galaxy proves the lethality of the stars. The universe does not care about the complexity of a biosphere. The universe only obeys the laws of physics. The Milky Way galaxy is approximately 13.6 billion years old. Our solar system, by comparison, formed only 4.6 billion years ago. This fact means that for 9 billion years, the galaxy existed without us. During this immense stretch of time, billions of stars were born, existed, and died. Many of these stars were similar to the sun. Many of these stars had planets in the habitable zone, where liquid water could exist. If the evolution of life is a natural consequence of chemistry and physics, then life should have emerged on those worlds billions of years before the Earth even existed. If the process of evolution required 4 billion years for humans to develop from single-celled organisms, then a civilization that started 8 billion years ago should be 4 billion years ahead of us. Such a civilization would have colonized the entire galaxy by now. Such a civilization would have reshaped whole star systems and built structures visible across the void. Yet, when we look at the stars, we see nothing but the cold light of physics. We see no signals, we see no megastructures, we see a silent gallery. This silence is the heart of the paradox of Fermi. The universe has had more than enough time to fill the galaxy with life, yet the galaxy remains stubbornly empty. The silence is not a lack of potential. The silence is a lack of continuity. The resolution to this paradox may lie in the chemical evolution of the galaxy. In the early universe, heavy elements did not exist. The first stars were made almost entirely of hydrogen and helium. These stars could not form rocky planets because iron, silicon, and oxygen did not exist. However, as these first stars died, these stars forged heavier elements in their cores and scattered them into space. This process is known as metallicity. Astronomers like Charles Lineweaver have mapped the buildup of these elements over cosmic time. The data shows that the galaxy became habitable for terrestrial planets about 8 billion years ago. This timeline leaves a 4 billion year head start over the Earth. However, the same star formation that creates the heavy elements for planets also creates the massive stars that produce gamma-ray bursts. In the early galaxy, the rate of star formation was much higher than the current rate. This high rate means that while the first rocky planets were forming, the rate of lethal cosmic resets was also at a peak. A planet in the young Milky Way might have developed life, but that life would have been reset by a gamma-ray burst every few million years. The galaxy was a factory for planets, but the cosmos was also a slaughterhouse for biology. Intelligence requires long-term stability, a commodity that was in short supply during the first 9 billion years of galactic history. Imagine the history of the galaxy as a vast library containing billions of books. Each book represents the story of a planet. In some books, the story never gets past the first chapter because the planet is too hot or too cold. In other books, life begins, but the story is cut short. Now, imagine that every few years, a fire breaks out in a different section of the library. The fire does not destroy the whole building, but the fire burns every book in a specific wing. If the fires happen often enough, no book will ever be finished. A reader walking into the library will find millions of half-written stories, but not a single completed novel. This condition represents the state of the galaxy. The fires are the gamma-ray bursts. The half-written stories are the worlds where life began but was extinguished before intelligence could emerge. We are the one book that happened to be shelved in a corner that the fire never reached. We are the only completed story in a library of ashes. This metaphor helps us understand that the silence of the galaxy is not necessarily a lack of life. The silence is a lack of survivors. The history of the Milky Way is not a steady progression. The history of the Milky Way is a series of resets that have prevented the rise of a galactic civilization. James Annis proposed in 1999 that the galaxy is currently undergoing a phase transition. A phase transition occurs when a suppressive force drops below a certain threshold, allowing a new state of equilibrium to emerge. Consider water freezing into ice. As the temperature drops, nothing seems to change until the water reaches exactly 0 degrees Celsius. Suddenly, the entire structure of the liquid shifts into a solid. Annis argued that the suppressive force in our galaxy is the rate of gamma-ray bursts. In the past, the rate was too high for intelligence to evolve anywhere. But as the galaxy ages, the star formation rate slows down. The time between lethal resets grows longer. We are existing in the moment when the average time between bursts has finally exceeded the 4 billion years required for the evolution of intelligence. This finding suggests that the galaxy is not empty because life is rare. The galaxy is empty because the reset clock only recently slowed down enough to allow any civilization to reach the finish line. We are not the first because we are special. We are the first because we are the only ones who reached the threshold at the same time the universe stopped screaming. The galaxy is waking up from a long, radioactive nightmare. This realization feels humbling and terrifying. This finding means that our entire history, from the first stone tools to the launch of the James Webb Telescope, has occurred within a rare window of cosmic stability. We have spent our existence in a pocket of calm in a storm that has lasted for billions of years. This window is not guaranteed to last. The astrophysical regulation model suggests that we are at a threshold. We are the first generation of life in this galaxy that is even aware of the lethal clock. We are the first observers who can look at the stars and understand the threat. This unique position gives us a responsibility that no other life form in the history of the Earth has ever held. We are the guardians of a 4 billion year miracle. If we do not learn to mitigate these cosmic threats, we will become just another half-finished book in the Library of Ashes. The time between resets is increasing, but the next burst could be traveling toward us right now at the speed of light. We would not see the threat coming until the sky turned to blue fire. In 2014, astrophysicists T.C. Piran and Raul Jimenez published a study that quantified the lethality of the Milky Way. Using data on the distribution of gamma-ray bursts and the metallicity of our galaxy, these researchers calculated the probability of a life-threatening hit on Earth. The results were a wake-up call for the scientific community. The study found that a 90% probability exists that a lethal gamma-ray burst has struck the Earth within the last 5 billion years. More specifically, a 50% chance exists that a burst caused a mass extinction event within the last 500 million years. This finding means that the history of life on the Earth is not a steady climb toward complexity. The history of life on the Earth is a series of narrow escapes. We often assume that the extinction of the dinosaurs was the most significant event in our past. But according to the math of Piran and Jimenez, the dinosaurs might have been the lucky ones. At least the dinosaurs were killed by a rock we can see. A gamma-ray burst is an invisible killer that travels at the speed of light. By the time the radiation reaches a planet, the damage is already done. We are residing on a world that has likely been sterilized and reset multiple times, and we are only here because the most recent resets were not quite powerful enough to finish the job. The most compelling evidence for a past gamma-ray burst hit comes from the Ordovician mass extinction. Approximately 440 million years ago, 85% of all marine species vanished from the Earth. For decades, geologists blamed this event on a sudden ice age, but in 2004, Adrian Mellett proposed a different cause. Mellett noticed that the patterns of extinction in the Ordovician record were unusual. Species that resided in the shallow parts of the ocean were hit much harder than species that resided in the deep. This pattern is exactly what a gamma-ray burst would produce. The gamma rays would destroy the ozone layer, allowing ultraviolet light to penetrate the surface waters. This radiation would kill the plankton and the shallow water organisms while leaving the deep sea life relatively unharmed. Furthermore, the cooling of the planet that triggered the Ice Age could have been caused by the nitrogen dioxide fog produced by the burst. The Ordovician extinction might be the smoking gun of a cosmic reset. If this hypothesis is correct, then the history of life on the Earth was shaped by a dying star thousands of light years away. Our very existence as land-dwelling mammals might be a direct result of how the ecosystem recovered from a burst of radiation that lasted less than 10 seconds. To understand our situation, imagine playing a game of Russian roulette. But instead of one revolver with 6 chambers, imagine 1,000 revolvers, each with 1,000 chambers. The galaxy is constantly pulling the trigger. Most of the time, the chamber is empty. The burst misses the Earth, or the burst is too far away to be lethal. But every few 100 million years, the hammer falls on a loaded round. This constant threat is the reality of life in a high-threat universe. We have been playing this game for 4 billion years. Every time the Earth was hit, life was pushed back to the brink. Some species were wiped out. Some ecosystems collapsed. But a few survivors always remain to restart the clock. We are the descendants of those survivors. We are the ones who happened to be in the deep water when the sky turned blue. We are the ones who happened to be in the right burrows when the radiation spiked. This metaphor highlights the statistical impossibility of our survival. We are not the masters of the game. We are just the players who have not lost yet. Our survival is not a biological inevitability. Our survival is a statistical anomaly. The idea of a galactic reset suggests that the paradox of Fermi is not a problem of biology, but a problem of timing. In the high-density regions of the inner galaxy, the rate of gamma-ray bursts is so high that life never has a chance to develop beyond the simplest forms. These regions are essentially permanent dead zones. Only in the outskirts of the galaxy, where the stars are spread thin, can a planet hope to find a few billion years of peace. This scarcity of stars creates a galactic habitable zone, a thin ring of safety where the conditions for life and the conditions for survival overlap. But even in this zone, the safety is relative. A reset can happen at any time. This volatility means that the galaxy is likely full of worlds that are currently in the middle of a 4 billion year climb, only to be knocked back down before they reach the summit. The Great Filter is not a wall that civilizations fail to climb. The Great Filter is a cosmic hand that periodically brushes the ladder clean. We are simply the only ones who have climbed high enough to notice the hand. We have spent decades looking for a galactic community, unaware that we were the only ones who reached the top of the ladder during a moment of silence. This perspective brings us to the most significant realization of all. Humanity represents the first generation of observers in the history of the galaxy who can see the clock. We have become the first who can measure the radiation, map the stars, and calculate the probabilities. This knowledge changes the stakes of our existence. In the past, life was a passive victim of the cosmos. Now, life has the potential to become an active participant. We are reaching the point where we can begin to think about galactic mitigation. We can imagine building shields, moving planets, or spreading life to multiple star systems to ensure that a single burst cannot extinguish our story. The paradox of Fermi is a warning. The warning tells us that no one else has ever succeeded in doing this. Or if these civilizations did, these civilizations are so rare that we cannot find them. We are at a threshold. We are the fragile watchers of a lethal clock. The choice to transform from a survivor into a guardian begins now. The clock is ticking. and the choice is ours. Our journey into the heart of this cosmic mystery is only beginning. We have faced the lethal flash of the gamma-ray burst, but the galaxy holds deeper layers of violence. To understand the true scale of the filter, we must look beyond the individual stars and examine the structure of the galaxy. We must find the shores where life can safely anchor in a sea of radiation. Those shores are hard-won. In a galaxy defined by the flash of blue fire, a safe harbor requires far more than distance. A sanctuary requires the perfect timing of a cosmic pause. The silence we observe is not a lack of life. The silence represents a scream that the laws of physics cut short. We exist in a shooting gallery where the triggers are pulled by the collapse of distant stars. To understand our survival, we must first confront the ghosts of the dead zones, those vast stretches of the cosmos where the reset clock never stops ticking. The history of the Milky Way is defined by these flashes of blue fire, erasers of biological potential that have haunted the universe for billions of years. To find the origin of this violence, we must look at the stars that refuse to grow old with grace. The search for these ghosts begins in the 90% of galaxies that are effectively sterilized ruins. These stellar systems are not empty voids without planets or stars. Instead, these are galaxies where the rate of gamma-ray bursts is so high that no world can ever find a sanctuary. In these systems, a lethal flash occurs every billion years across the entire galactic disk. This extreme frequency represents a hard limit on the evolution of intelligence. To understand why these dead zones exist, we must look at the dwarf galaxies that populate the local group and beyond. Systems like the Sagittarius dwarf or the Small Magellanic Cloud are essentially factories for cosmic violence. These smaller galaxies contain vast clouds of primordial gas that have not yet been enriched with the heavy elements forged in generations of stars. This lack of chemical complexity is the fuel for the reset machine. In these environments, the star-to-burst ratio is skewed toward catastrophe. For every 1,000 stars born in a dwarf galaxy, the probability of a lethal gamma-ray burst is significantly higher than in a mature, high metallicity system like the Milky Way. The lethal mechanics of these dwarf galaxies are driven by a specific stellar population known as Wolf-Rayet stars. These are massive, hot stars that have lost their outer hydrogen envelopes and are burning helium or heavier elements in their cores. The undressing of these stars is a critical stage in the path to a gamma-ray burst. To understand the physics of this weapon, we must look at the internal struggle of a dying giant, a star having a midlife crisis, except the sports car is a black hole and the breakdown destroys several solar systems. In a mature star like the Sun, the light produced in the core must fight the way through a thick atmosphere of gas. If that gas contains heavy elements like iron or silicon, the atoms act like a thick forest, trapping the photons and transferring the energy to the outer layers of the star. This interaction creates powerful stellar winds that push the material away into space. As the star sheds this mass, the star also sheds angular momentum, slowing the rotation of the star over millions of years. This slowing of rotation is the salvation of any nearby planet. A star that rotates slowly cannot produce the focused, relativistic jets of a gamma-ray burst. Because the heavy elements that would trap the light are missing in the low metallicity environments of the dead zones, the atmosphere of the star is transparent. Photons blast through the gas without pushing the material away. Consequently, the star remains massive and retains the immense rotational energy of the star until the final moment of collapse. This conservation of spin is the key to the galactic reset. Imagine a figure skater spinning on the ice. When the skater pulls in their arms, the spin accelerates. A low metallicity star is like a skater who never extends their arms. The star keeps the speed of the spin as the star collapses. This rotational energy creates a powerful internal dynamo, generating magnetic fields that are billions of times stronger than the magnetic field of the Earth. When the core of such a star finally fails, these magnetic fields act as a nozzle funneled into two narrow beams of radiation. This high-energy flux represents a lethal interaction with the atomic structure of the universe. The gamma rays do not simply reflect, they penetrate, shattering the bonds that hold biology together. If such a beam strikes a planet, the atmospheric shielding that protects life becomes a liability. The radiation triggers a catastrophic transformation of the upper atmosphere. Nitrogen and oxygen are stripped of their electrons, forging a veil of nitrogen dioxide that turns the sky into a furnace of toxic haze, choking the light of the sun. The lethality of these snipers is not limited to their immediate neighborhood. A single gamma-ray burst can sterilize a planet from a distance of over 10,000 light-years. To understand the scale of this threat, we must consider the volume of the lethal zone. If a burst occurs in the center of a dense star cluster, the radiation can strip the atmospheres of every habitable world in that cluster. The lethal radius depends on the energy of the burst and the duration of the flash. A single burst generates over 10 to the power of 52 ergs of energy within a span of less than 100 seconds. This concentrated blast of gamma rays creates a cylinder of death that spans thousands of parsecs. This volume represents a galactic-scale quarantine. Piran and Jimenez demonstrated that this quarantine is most effective in the high-density regions of the galactic core. Near the center of the Milky Way, the probability of a lethal hit within any 500 million year window is nearly 100%. These central star systems are locked in a permanent loop of creation and destruction, a radioactive prison where life never gets the chance to escape the simplest chemical stages. In the galactic center, stars are packed so tightly that the sky of a planet would never know true darkness. But this proximity is a death sentence. While a planet in the outskirts might face a reset once every billion years, a world near the core exists in a crossfire of overlapping lethal radii. A gamma-ray burst from one star might destroy the ozone layer, and before the atmosphere can recover, a supernova from a neighboring system could strip the air away entirely. This density of violence creates a permanent dead zone. These galaxies are cosmic factories that produce billions of worlds. But these galaxies are also cosmic slaughterhouses that destroy every story before the first chapter is finished. Viewing these systems reveals a graveyard of potential, billions of worlds identical to the Earth that were struck by the relativistic jets and turned into brown toxic ruins. In that silence, we hear the sound of a reset clock that never allows a single second of peace. Furthermore, the laws of stellar evolution in these low metallicity environments ensure that the board is cleared before any civilization can even place the first piece. Consequently, the universe appears to have a chemical preference for violence. A cosmic landlord who renovates the apartment and then immediately sets the apartment on fire because the drapes are the wrong shade of iron. The primary driver of this lethality remains the metallicity of the system. This chemical complexity, forged in the hearts of previous stars, acts as the primary builder of rocky worlds like the Earth. But these metals also influence how stars die. As we have seen, the opacity of the atmosphere of a star depends on the concentration of these heavy elements. This chemical barrier creates a fundamental paradox. Life requires the same metals that eventually save life from the blue fire. This contradiction is the irony of the cosmos. The universe builds a biological sanctuary and then immediately attempts to incinerate the structure because the foundations lack the correct chemical reinforcement. The rocky worlds formed in the early universe were the most vulnerable because those worlds lacked the very shielding provided by a metal-rich environment. They were built from the rubble of the first stars, but they were positioned in a galaxy that was still a radioactive furnace. The buildup of iron and silicon in the Milky Way was a slow, agonizing process of tempering the galaxy, a chemical evolution that lasted for billions of years before the first safe harbor could form. The mechanics of this galactic regulation are driven by the evolution of the star formation rate. As a galaxy ages, the supply of gas and dust is consumed. The production of massive stars with short lifespans slows down. This slowing of star birth is the key to the sanctuary. Our species occupies the rare window where the duration between lethal flashes has finally surpassed the 4 billion-year threshold needed for intelligence to emerge. The data indicates that the Milky Way is finally emerging from a long radioactive slumber. This phase transition occurs when a suppressive force drops below a certain threshold, allowing a previously forbidden process to occur. In this case, the suppressive force is the rate of gamma-ray bursts. This decrease in frequency represents far more than a change in timing. This shift represents a fundamental reconfiguration of galactic potential. To understand the magnitude of this transition, we must map the history of the Milky Way across 3 distinct eras of cosmic violence. This map is defined by the concept of mean time between failure, a metric used in engineering to describe the reliability of a system. In this context, the system is a planetary biosphere. During the Age of Chaos, the Milky Way was a stellar furnace. The high concentration of low metallicity gas fueled the creation of hypermassive stars that burned with a white-hot intensity. These giants did not simply die. They detonated with a frequency that modern astronomers would find inconceivable. In this primordial environment, the cosmic noise was a constant scream. For every million years of peace, a dozen lethal flashes would sweep across the disk. This frequency created a universal suppression of complexity. Biological potential existed, but the chemical foundations were shattered before the first cells could even organize. No story could be written because the ink was always burning. We exist in the third era, the Age of the Window. Approximately 4 billion years ago, the star formation rate in the Milky Way crossed a critical threshold. The mean time between failure for the galactic disk finally began to exceed the 4 billion-year window required for the development of technological intelligence. This shift represents the most important event in the history of our galaxy. The Milky Way did not become habitable because of a miracle of biology. The Milky Way became habitable because the physics of the stars finally allowed a pause. The pause represents the biological zero of the system, the moment when the suppressed potential of the cosmos was finally allowed to break through the radioactive ceiling. Such synchronization explains why the stars are silent. Everyone in the galaxy is starting at the same time because the galaxy only recently stopped screaming. The transition extends far beyond the Earth. This shift represents a galactic scale change in the probability of survival. We are part of a wave of potential that is finally breaking across the stars. The silence is the sound of billions of worlds finally catching their breath. However, the threshold for intelligence requires far more than biological survival. Intelligence requires a specific scale of complexity, a neural density that is incredibly expensive, in terms of energy and time. To understand this metabolic bottleneck, imagine a city during a power shortage. Under normal conditions, the city can afford to run streetlights, hospitals, and high-speed data centers. But if the power grid is constantly being hit by storms, the city must prioritize. The hospitals and the water pumps stay on, but the expensive data centers are shut down to conserve energy. Life on a planet operates on a similar energy budget. For hundreds of millions of years, the world was dominated by reptiles and fish that prioritized efficient, low-energy survival. These organisms were like the emergency pumps of the city. They were efficient and resilient, but they lacked the processing power to build a civilization. They were optimized for a world where the environment could collapse at any moment. In a high-reset universe, reptilian efficiency is the only viable strategy. If the world is likely to end every 50 million years, no evolutionary benefit exists to building a brain that takes 200 million years to mature. The energy is better spent on armor, eggs, and rapid reproduction. The transition to high intelligence required a massive biological leap known as the encephalization jump. Approximately 200 million years ago, a new class of organisms emerged, specifically mammals and birds. These creatures prioritized neural complexity over metabolic efficiency. To understand the magnitude of this shift, we must look at the metabolic cost of a large brain. The brain is an energy sink that never sleeps. In a human, the brain consumes 20% of the total energy of the body while representing only 2% of the mass. This energy requirement creates a fundamental vulnerability that makes a species incredibly brittle. To maintain a large brain, an organism requires a constant, high-quality supply of food and a stable thermal environment. This requirement is the expensive tissue hypothesis. In the evolution of primates, the gut size decreased as the brain size increased, a biological trade-off that required a shift to high-calorie food. This trade-off is only possible in a world where the food supply is not being periodically obliterated by cosmic radiation. High intelligence is a luxury that requires a long-term guarantee of stability. Evolution does not fund expensive neural research if the laboratory is likely to explode every Tuesday. Imagine a specialized high-performance racing engine. This engine can produce incredible speed and power, but the engine requires specific fuel, constant maintenance, and a perfectly smooth track. If the track is full of potholes, or the fuel is contaminated, the engine will seize and fail. A simple tractor engine, by comparison, can run on low-grade fuel and handle the roughest terrain. For billions of years, the cosmos was a rough track. The gamma-ray bursts were the potholes that destroyed the high-performance engines of evolution. Every time a lineage attempted to build a large brain, the environment would shift. The brown fog of nitrogen dioxide would block the sun and collapse the food web. The simple tractor engines, the reptiles, and the simple organisms would survive by slowing their metabolism or entering a state of stasis. But the racing engines, the creatures with the large brains and the high energy requirements, would be obliterated within weeks. They were at the margin of the energy budget of the world, and the cosmos did not provide a buffer for the expensive luxury of thought. The history of the galaxy is a graveyard of racing engines that never reached the finish line. The high frequency of gamma-ray bursts in the Milky Way acted as a hard ceiling on this neural complexity. Life was allowed to exist, but life was never allowed to get smart. The Great Filter does not act as a simple barrier or a fortress wall. The filter is a metabolic bottleneck. The resets prevent the rise of organisms that are expensive enough to be smart. The galaxy was full of simple life for billions of years, but the reset clock always struck midnight before the neural jump could occur. The silence of the galaxy is the silence of worlds where the animals never learned to dream because the sky always turned to fire before the first dreams could form. We are existing in the first moment of galactic history where the stability of the environment has lasted long enough for the expensive tissue of the brain to become a viable evolutionary investment. We are the beneficiaries of a cosmic peace treaty that we did not sign. This peace treaty is not a universal right. The treaty is a geographic privilege, a lottery win written into the very architecture of the Milky Way. To understand why we are alone, we must stop looking at the stars as individual lights and start looking at the galaxy as a machine with a narrow habitable core. The silence of the universe is not a mystery of biology. The silence is a consequence of where the stars are born. We exist in a thin, shimmering ring of stability known as the galactic habitable zone. This concept, formalized by astrophysicist Charles Lineweaver and colleagues in a 2004 paper published in the journal Science, represents the first attempt to define the boundaries of the cosmic cradle. The findings suggest that the vast majority of the Milky Way is not a home for life, but a graveyard of chemical poverty or a furnace of radioactive fire. The story of the galactic habitable zone begins at the Australian National University. There, a team of researchers led by Lineweaver attempted to synthesize decades of data on stellar evolution and planetary formation. At the time, the prevailing view of the Fermi Paradox was that the entire galaxy was a potential garden. If a star had a planet at the right distance, life should emerge. However, Lineweaver argued that this view ignored the large-scale architecture of the cosmos. The researchers looked at the distribution of heavy elements and the frequency of lethal astrophysical events across the 100,000 light-year span of the Milky Way. They discovered that the conditions for life are not distributed evenly. Instead, the conditions are concentrated in a ring that sits between 25,000 and 30,000 light-years from the galactic center. This narrow band is the only region where the chemical building blocks are abundant enough to form planets. But the radioactive threats are infrequent enough to allow those planets to survive. Imagine the Milky Way as a massive, rotating dartboard. The center of the board is where most of the darts are landing. These darts are the high-energy photons from supernovae and the relativistic jets of gamma-ray bursts. If a target sits in the center, the target will be hit constantly. The outer edge of the board, by contrast, is mostly empty. Very few darts land there because very few stars are present to throw those darts. This outer edge is a safe place to hide, but the edge is also a desert. If a builder wants to build a house, that builder needs wood and stone. In the outer galaxy, the wood and stone of planetary formation, the heavy elements, are missing. A traveler might find a star, but that traveler will never find an Earth. The galactic habitable zone is the narrow ring on that dartboard where the frequency of the darts is low enough to survive, but the supply of building materials is high enough to construct a home. Humanity resides in the cosmic suburbs, far enough from the dangerous city center to avoid the violence, but close enough to the industrial heart of the galaxy to have the materials needed for existence. The mystery of this ring lies in the timing of the formation of the zone. According to the models of Lineweaver, the galactic habitable zone did not always exist. In the early history of the Milky Way, the entire galaxy was a dead zone. The metallicity was too low everywhere to form rocky planets, and the rate of cosmic resets was too high to allow any early biology to flourish. The ring only began to form approximately 8 billion years ago. As the chemical complexity of the galaxy slowly increased, and the star formation rate began to stabilize. The evidence implies that for the first 5 billion years of galactic history, the universe was effectively sterile. Any civilization that attempted to emerge during this era was likely extinguished by the first radioactive flash. The data suggests that Earth was among the very first planets born into the first safe window of the Milky Way. We are not latecomers to the cosmic stage. We are the opening act, performing in a theater that only recently opened the doors. The existential implication of the galactic habitable zone is profound. If the ring of life is as narrow as the data suggests, then the number of potential neighbors drops by orders of magnitude. We are not looking for a needle in a haystack. We are looking for a needle in a haystack where 90% of the hay is currently on fire. The silence of the galaxy is the silence of the exclusion zones. We look toward the center of the Milky Way and see billions of stars, but we fail to see that those stars are locked in a radioactive prison. We look toward the outer edge and see vast reaches of space, but we fail to see that those reaches are empty of rocky ground. Our survival is a matter of luck, a consequence of being born in the right neighborhood at the right time. The galactic habitable zone is the only reason the story of humanity was ever allowed to move beyond the first page. The inner galaxy is a crowded city. Plenty of opportunities exist, but the rent is paid in radioactive fire. This region is a high-energy real estate market where every apartment comes with a complementary supernova. A sky so bright would exist that a person would never need a flashlight, but that person would also never need a future. This geographic restriction leads to the most significant chemical hurdle in the cosmos. Heavy elements, specifically the iron and silicon that form the rocky foundation of our world, act as the primary builder of planets. But these metals also influence how stars die. Metallicity is a measure of chemical complexity, and the concentration of these heavy elements in a star determines the opacity of the stellar atmosphere. This chemical barrier creates a fundamental paradox. Life requires the same metals that eventually save life from the blue fire of a gamma-ray burst. This contradiction represents the irony of the cosmos. The universe builds a biological sanctuary and then immediately attempts to incinerate the structure because the foundations lack the correct chemical reinforcement. The buildup of iron and silicon in the Milky Way was a slow, agonizing process. This chemical evolution lasted for billions of years before the first safe harbor could form. The rocky worlds formed in the early universe were the most vulnerable because those worlds lacked the very shielding provided by a metal-rich environment. They were built from the rubble of the first stars, but they were positioned in a galaxy that remained a radioactive furnace. We must consider the outer galaxy as a chemical desert. The outer galaxy is a place so empty that even the atoms feel lonely. This area represents a cosmic social distancing campaign that has lasted for 10 billion years. The mechanics of this galactic regulation are driven by the evolution of the star formation rate. As a galaxy ages, the supply of gas and dust is consumed. The production of massive stars with short lifespans slows down. This slowing of star birth provides the key to the sanctuary. Our species occupies the rare window where the duration between lethal flashes has finally surpassed the 4 billion year threshold needed for intelligence to emerge. The data indicates that the Milky Way is finally emerging from a long radioactive slumber. This phase transition occurs when a suppressive force drops below a certain threshold, allowing a previously forbidden process to occur. In this case, the suppressive force is the rate of gamma-ray bursts. James Annis proposed in 1999 that the galaxy is currently undergoing this phase transition. Consider water freezing into ice. As the temperature drops, nothing seems to change until the water reaches exactly 0 degrees Celsius. Suddenly, the entire structure of the liquid shifts into a solid. Annis argued that the suppressive force in our galaxy is the rate of gamma-ray bursts. In the past, the rate was too high for intelligence to evolve anywhere. But as the galaxy ages, the star formation rate slows down. The time between lethal resets grows longer. We are existing in the moment when the average time between bursts has finally exceeded the 4 billion years required for the evolution of intelligence. This finding suggests that the galaxy is not empty because life is rare. The galaxy is empty because the reset clock only recently slowed down enough to allow any civilization to reach the finish line. Our position as pioneers is not a mark of cosmic favor. The galactic habitable zone simply became chemically enriched at the precise moment when the astrophysical violence subsided, allowing the first survivors to push through the radioactive ceiling. The galaxy is transitioning from a furnace into a nursery. To understand the magnitude of this transition, we must map the history of the Milky Way across 3 distinct eras of cosmic violence. This map is defined by the concept of mean time between failure, a metric used in engineering to describe the reliability of a system. In this context, the system is a planetary biosphere. During the Age of Chaos, the Milky Way was a stellar furnace. The high concentration of low metallicity gas fueled the creation of hypermassive stars that burned with a white-hot intensity. These giants did not simply die. The stars detonated with a frequency that modern astronomers would find inconceivable. In this primordial environment, the cosmic noise was a constant scream. For every million years of peace, a dozen lethal flashes would sweep across the disk. This frequency created a universal suppression of complexity. Biological potential existed, but the chemical foundations were shattered before the first cells could even organize. No story could be written because the ink was always burning. The sanctuary we occupy belongs to the 3rd era of galactic history. 4 billion years ago, the metallicity of the disk finally reached the threshold required for rocky world formation, while the frequency of sterilizing bursts simultaneously dropped below the lethal ceiling. This chemical and physical convergence represents the most significant geographic shift in the history of our galaxy. The habitability of our narrow ring is not a default state of the cosmos. It is the product of a slow alignment that has only recently stabilized. The pause represents the biological zero of the system, the moment when the suppressed potential of the cosmos was finally allowed to break through the radioactive ceiling. Such synchronization explains why the stars are silent. Everyone in the galaxy is starting at the same time, because the galaxy only recently stopped screaming. The transition extends far beyond the Earth. This shift represents a galactic-scale change in the probability of survival. We are part of a wave of potential that is finally breaking across the stars. The silence is the sound of billions of worlds finally catching their breath. The idea of a galactic reset suggests that the paradox of Fermi is not a problem of biology, but a problem of timing. The Great Filter is not a wall that civilizations fail to climb. The Great Filter is a cosmic hand that periodically brushes the ladder clean. We are simply the only ones who have climbed high enough to notice the hand. For decades, we searched the cosmos for neighbors, never realizing that our thin ring of stability was the only refuge where the ladder of complexity could be climbed at all. This condition represents a biological ground-together day where every civilization is constantly being sent back to the start. The galaxy is a 5-minute window on a 2-minute level. No matter how well a species plays, the species can never win if the clock resets before the finish line. The high frequency of gamma-ray bursts in the Milky Way acted as a hard ceiling on neural complexity. Life was allowed to exist, but life was never allowed to get smart. The resets prevent the rise of organisms that are expensive enough to be smart. The galaxy was full of simple life for billions of years, but the reset clock always struck midnight before the neural jump could occur. The silence of the galaxy is the silence of worlds where the animals never learned to dream, because the sky always turned to fire before the first dreams could form. We occupy the first epoch in galactic history, where the chemical abundance and astrophysical calm of the habitable zone have persisted long enough for the metabolically expensive brain to become a viable biological strategy. We are the inheritors of a geographic lottery that we never entered. However, a deeper layer of the filter exists. To understand why the stars remain empty, we must examine the specific mechanics of stellar nucleosynthesis. Every atom in the human body, from the iron in the blood to the calcium in the bones, was forged in the heart of a dying star. This process, known as stellar nucleosynthesis, is the engine of complexity in the universe. During the first few minutes after the Big Bang, the universe consisted of only hydrogen, helium, and a trace of lithium. These light elements are the primary fuel for stars, but these elements cannot build a world. To build a world, the universe required hundreds of millions of years of stellar labor. In the core of a star, gravity crushes the atoms together with such force that the atoms fuse. Hydrogen fuses into helium, helium fuses into carbon and oxygen. This fusion releases the energy that makes the star shine, but the process does not stop there. In the final moments of the life of a massive star, the core becomes a furnace of incredible intensity. The star fuses heavier and heavier elements until the star reaches iron. Iron represents a chemical dead end for stellar fusion. To fuse elements heavier than iron requires more energy than the fusion produces. Consequently, when the core of a star becomes solid iron, the engine shuts down. The star can no longer produce the outward pressure needed to resist the crushing weight of gravity. In a fraction of a second, the star collapses. This collapse triggers a supernova explosion, a detonation so powerful that the explosion creates the heaviest elements in the periodic table, like gold, platinum, and uranium. These elements are scattered into the interstellar medium, where the elements mix with clouds of gas to form the next generation of stars and planets. This process is the industrial cycle of the galaxy. Every world is built from the ashes of a previous world. But this cycle is also a source of lethal danger. The same supernovae that provide the iron for the core of the Earth also produce the cosmic rays and gamma rays that can sterilize a planet. The chemical enrichment of the galaxy is not a uniform process. Astronomers have found that the metallicity of the Milky Way decreases as a traveler moves away from the center. This gradient exists because the density of stars is highest at the core. More stars mean more cycles of birth and death, which means more heavy elements. In the inner galaxy, the metallicity is twice as high as the metallicity in the solar neighborhood. This high metallicity means that rocky planets are extremely common in the galactic center, but this abundance comes at a price. The inner galaxy is also the most violent region of the Milky Way. The high density of stars leads to a high frequency of supernovae and gamma-ray bursts. A planet at the galactic center might be rich in iron and gold. But that planet will be hit by a lethal burst of radiation every few million years. The chemical construction site is constantly being demolished by the very forces that provide the materials. By contrast, the outer galaxy is chemically poor. Beyond 40,000 light-years from the galactic center, the metallicity drops to a level that is too low to form terrestrial worlds. Stars in these regions are made almost entirely of hydrogen and helium. These stars might have gas giants like Jupiter, but these stars lack the iron and silicon to build a rocky cradle for life. The outer galaxy is a quiet, empty wilderness. The stars are safe from the violence of the center, but the stars are also lonely. No planets exist to watch the sunrise. This chemical poverty is the ultimate limit on the distribution of life. The universe decided that if a species wants a rocky world, that species must pay the iron price. This price is the risk of cosmic sterilization. The galactic habitable zone is the narrow region where the iron price is affordable. In this zone, the metallicity is high enough to build an Earth, but the star density is low enough to avoid a constant barrage of radiation. We are sitting in a chemical sweet spot. This sweet spot is not a permanent feature. As the galaxy ages, the metallicity of the outer regions slowly increases. The ring of habitability is moving outward like a ripple in a pond. But the ripple is slow. Billions of years are required for a new region of the galaxy to become chemically ready for life. We are the first generation of worlds to occupy this expanding front. The silence we hear is the sound of a galaxy that is only now becoming chemically and physically prepared for the rise of intelligence. To understand the scale of this preparation, we must consider the metabolic requirements of high intelligence. A large brain is the most expensive biological investment a species can make. In humans, the brain consumes 20% of the oxygen and energy of the body, despite making up only 2% of the total mass. This high cost creates a fundamental vulnerability. A brain requires a constant, stable supply of energy. A brain cannot be shut down during a crisis. If the food supply collapses or the environment becomes too harsh, the brain is the first organ to fail. This metabolic bottleneck means that high intelligence can only evolve in a world that has been stable for hundreds of millions of years. For most of the history of the Earth, life was dominated by reptiles and simple organisms that prioritized metabolic efficiency over neural complexity. These creatures were the emergency pumps of the planet. They were designed to survive in a world where the environment could reset at any moment. High intelligence is a luxury that requires a long-term guarantee of peace. Evolution does not fund expensive neural research if the laboratory is likely to explode every Tuesday. For billions of years, the cosmos was a rough track, and the gamma-ray bursts were the potholes that destroyed the high-performance engines of evolution. Every time a lineage attempted to build a large brain, the environment would shift. The brown fog of nitrogen dioxide would block the sun and collapse the marine food web. The simple tractor engines, the reptiles and the microorganisms survived by slowing their metabolism or entering a state of stasis. But the racing engines, the creatures with the large brains and the high energy requirements, were obliterated. They were at the margin of the energy budget of the world, and the cosmos did not provide a buffer for the expensive luxury of thought. The history of the galaxy is a graveyard of these racing engines. We look at the stars and wonder why no one is calling. Perhaps the answer is that they never learned to speak because the sky always turned to blue fire before they could form the first words. We are the first generation in 4 billion years of galactic evolution, where the metallicity and the calm have aligned long enough for the neural investment to finally pay off. This realization changes the way we view our place in the cosmos. We are not just a biological accident. We are a geographic and chemical anomaly. We are the first observers who have been allowed to reach the summit of the neural mountain. This unique position brings a responsibility that no other life form has ever held. We are the guardians of a 4-billion-year pause in the cosmic scream. The astrophysical reset model suggests that the pause is not a guarantee of future safety. The resets are a permanent feature of the galactic machine. We have survived for 4 billion years, but the next burst could be traveling toward the Earth right now. The difference is that we can see the threat. We can measure the radiation. We can map the stars. We are the first generation of observers capable of understanding the lethal clock. We are the first who can begin to think about galactic mitigation. The choice to transform from a survivor into a guardian begins with the understanding of our isolation. The galactic habitable zone is a lonely sanctuary. The heavy elements that build our bodies are the same elements that fuel the weapons of our destruction. The universe is already reaching for the handle of the door to the sanctuary. We must learn to move faster than the reset. We must move beyond the cradle of the Earth and spread the story of life to the stars. The silence of the galaxy is not an absence of potential. The silence is a call to action. We are the fragile watchers of a lethal clock, and the silence of the stars is a reminder that the clock is still ticking. We have faced the geographic and chemical barriers of the Milky Way, but the galaxy holds even deeper layers of violence. To understand the true scale of the filter, we must look beyond the stars of our own galaxy and examine the structure of the universe itself. We must find the origin of the super resets that threaten not just planets, but entire galaxies. The search for the origin of these ultimate cosmic limits leads us to a paradox. The danger is not random. The danger is synchronized. The chemical maps of the galactic habitable zone reveal that the silence of the radio sky is not an accident. The silence is a consequence of timing. We are not late to the cosmic party. We are early, but being the first to wake up in a dark room brings a new kind of terror. If we are the opening act, then the stage is empty, not because the actors are dead, but because the curtains just opened. This shift in perspective forces us to confront a reality that is both exhilarating and isolating. The silence of the radio sky is not an indication of a failure of biology. The silence is the sound of a galaxy taking the first breath after billions of years of suffocation. The existential implication of this first mover status is a heavy burden. If we are part of the first wave of intelligence, we have no older siblings to guide our progress. No ancient ruins exist for us to study. No galactic libraries remain for us to consult. Humanity is the opening act of a theater that only recently opened the doors. This realization shifts our identity from latecomers to pioneers, but this shift also brings a terrifying realization. If every civilization is starting at the same time, then every civilization is facing the same first test. The galaxy has finally stopped screaming, but the silence may be temporary. We are existing in the first moment of stability, a brief pause in the cosmic reset, and that pause is the only chance we will ever receive. The threats we have examined so far are local. A star detonates, a black hole feeds, a beam of radiation sweeps across a disk. These events are the growing pains of a young galaxy. But as we move toward the horizon of the universe, we find threats that do not care about the position of a planet or the chemical makeup of a star. We find the super resets. These threats are catastrophes that endanger the structure of reality. The most absolute of these hard limits is known as the decay of the false vacuum. This phenomenon is the ultimate reset button, a cosmic hard limit that could erase the entire universe in a heartbeat. The study of vacuum stability emerged from the intersection of particle physics and cosmology. Researchers like Milan Cirkovic at the Astronomical Observatory of Belgrade have argued that we must look beyond the astrophysical regulation of our own galaxy to understand the true scale of the Great Filter. The false vacuum hypothesis suggests that the universe does not reside in a state of permanent stability. In the early 1980s, physicists Sidney Coleman and Frank DeLucia described how a more stable state of space could form as a bubble of true vacuum. This bubble would expand at the speed of light, incinerating every atom in the path of the bubble. No warning would precede the event. No defense could stop the expansion. The sky would not turn blue. The sky would simply cease to exist. Every star and every memory would be overwritten by a new set of physical laws that do not allow for the existence of matter. The mechanical deep dive into vacuum decay requires an understanding of the Higgs field. The Higgs field is the invisible energy that fills the universe and gives mass to fundamental particles. On July 4, 2012, scientists at the Large Hadron Collider in Switzerland announced a discovery that changed our understanding of this field. They had found the Higgs boson, a particle associated with the field, but the mass of the particle, approximately 125 gigaelectronvolts, was deeply unsettling. This specific mass suggests that the universe sits in a state of metastable equilibrium. To understand this, imagine a ball sitting on a ledge halfway down a mountain. The ball is stable as long as the ball stays on the ledge, but a deeper valley exists at the bottom of the mountain. If the ball is pushed over the ledge, the ball will fall to the bottom, releasing a massive amount of energy. The vacuum we occupy is that ledge. The bottom of the valley is the true vacuum. The trigger for this collapse is a process known as quantum tunneling. In the world of classical physics, a ball cannot move through a solid wall. But in the world of quantum mechanics, a small probability exists that a particle can simply appear on the other side of a barrier. If a tiny patch of space, smaller than a single atom, undergoes quantum tunneling into the true vacuum, the transition begins. This event would create a bubble of the new, more stable state of reality. The surface of this bubble would carry an immense amount of energy, moving outward at the speed of light. Because the bubble moves at the speed of light, the destruction arrives before the light from the event. We would never see the end coming. The universe would simply vanish, replaced by a new reality where the laws of physics are unrecognizable. Light would no longer travel. Atoms would no longer hold together. The concept of distance might cease to have meaning. The Higgs field would shift, and the forces that hold atoms together would dissolve. Protons would decay. Chemistry would become impossible. The universe would be scrubbed clean. Imagine the universe as a massive sheet of glass. This glass is perfectly clear, perfectly smooth, and seemingly permanent. We build our cities on the surface of the glass. We map the stars through the glass. But the glass is not a solid. The glass is a supercooled liquid that is technically in a state of transition. If a single pebble hits the glass with enough force, a crack begins to form. This crack travels faster than the speed of sound, spiderwebbing across the entire sheet in a fraction of a second. The decay of the false vacuum is that crack. The sheet of glass is the fabric of space and time. We are the microscopic organisms living on the surface, unaware that the entire foundation of our reality is under tension. The crack destroys more than the organisms, Crucially, the crack destroys the glass. This event is the ultimate reset, a hard limit that exists not in the stars, but in the vacuum of space. The mystery of this super reset lies in the timing. Some calculations suggest that the false vacuum is stable for trillions of years. Other models, incorporating the effects of black holes or high-energy cosmic rays, suggest the window could be much shorter. The researcher Milan Cirkovic has argued that these universal-scale threats act as a final, absolute filter. If a civilization survives the gamma-ray bursts and the supernovae, that civilization still faces the inevitable decay of the universe. The problem is that we cannot measure the tension of the glass. We can only look at the mass of the Higgs boson and realize that we are standing on a ledge. This situation creates a fundamental paradox of existence. The more we understand the laws of physics, the more we realize those laws might be temporary. This universal reset represents the ultimate end of the story. The astrophysical regulation model suggests that the galaxy is finally becoming a safe harbor for life. But the false vacuum model suggests the harbor is built on a foundation of sand. We are existing in a moment of local peace within a universe of global instability. This realization is the core of the cosmic perspective. The universe is a machine that builds and then destroys without a second thought. Our existence is a brief flash of complexity between two states of nothingness. We are the only ones who can see the ledge, and we are the only ones who can feel the weight of the potential fall. The synthesis of these cosmic threats leads to a singular model of existence. We are a flash in the dark. The history of the cosmos is not a long upward climb toward complexity. The history of the cosmos is a series of brief windows, a sequence of pauses in a much larger storm. We have looked at the galactic habitable zone and the synchronization of intelligence. We have looked at the lethal beams of the stars and the cracking glass of the vacuum. When we combine these layers, we find a universe that is far more lethal and far more fragile than the Drake equation ever suggested. Humanity is not a statistical inevitability. We are a statistical survivor. This flash-in-the-dark model was articulated by researchers like Dominic Schleicher and Stefano Bovino in a 2022 study. They developed a dynamical model for the development of civilizations that accounts for both the formation of stars and the astrophysical destruction mechanisms of the galaxy. Their results suggest that the number of civilizations is not a steady state. The number is a fluctuating population, constantly being pruned by the violence of the environment. The researchers suggest that non-equilibrium evolution allows for solutions in between extreme cases. The finding means the galaxy is not empty because life is rare. The galaxy is empty because the window of survival is narrow. We are the ones who happen to emerge during a rare 4 billion-year gap in the cosmic scream. The mechanical deep dive into this model involves the concept of the mean time between failure. For a planetary biosphere, the components are the atmosphere, the ozone layer, and the magnetic field. The astrophysical threats we have studied are the forces that break these components. Schleicher and Bovino found that the astrophysical effects change the number of intelligent civilizations by a factor of at least 2. But when they account for the synchronization of these events, the impact grows. The galaxy acts as a series of connected rooms. If the hallway catches fire, every room is affected. The mean time between failure for the entire Milky Way is the ultimate limit on how far any species can go. To understand the scale of this failure rate, consider the galaxy as a high-performance supercomputer. In this analogy, the hardware is the planetary biosphere. The cooling system is the atmosphere. The memory banks are the genetic code of every living organism, and the operating system is high-level intelligence. Every computer engineer knows that complex software requires a stable power supply. You cannot run a simulation that takes 1 billion years to compute if the power grid fails every 100 million years. In the early Milky Way, the galactic power grid was a chaotic mess. Gamma-ray bursts acted like voltage spikes that fried the motherboard before the boot sequence could even finish. The memory banks of DNA were constantly being wiped by radiation, forcing the system to restart from basic code. The hard drives of the fossil record are full of corrupted files, entire lineages of data that were deleted by a sudden surge of energy from a dying star. For billions of years, the lightning was so frequent that no computer could stay on long enough to load the desktop. The operating system of consciousness never had a chance to initialize. We are the first generation of hardware that has been allowed to stay on long enough to run the first lines of complex code. But the lightning has not stopped. The lightning has only slowed down. The mean time between failure has increased, allowing for longer uptime, but the probability of a catastrophic crash remains a permanent feature of the system architecture. This increasing reliability of the galactic hardware has profound implications for the biological software of life. In a high-reset environment, evolution favors organisms that are simple, resilient, and fast-growing. No biological benefit exists for building a brain that takes 20 years to mature if the world is likely to end in 15. But as the mean time between failure increases, the constraints on complexity begin to loosen. We are currently living through a biological gold rush, a rare moment when the energy of the biosphere is no longer being consumed by constant reconstruction. For the first time in galactic history, the survivors have enough time to become observers. The expensive tissue of the neural network has finally become a profitable investment because the cosmic storms have moved to the horizon. Consider a massive forest during a lightning storm. Each tree represents a star system. Each leaf represents a potential planet for life. The lightning strikes are the gamma-ray bursts and the supernovae. If the lightning strikes every minute, the forest remains a collection of charred stumps. No tree ever grows tall enough to reach the canopy. But if the storm breaks, if the lightning only strikes once every hour, the trees have a chance. They begin to grow, they begin to branch out, but the forest remains a dangerous place. The ground is dry, the heat is intense. A single strike can still trigger a fire that clears the entire forest. Life is the green sprout that appears in the ashes of the last fire, hoping that the next strike is far enough away to allow the sprout to reach the sun. We are the trees that have finally reached the canopy, but we are still living in a forest that is designed to burn. The mystery of our survival is the core of the timing problem. If the galaxy is currently undergoing a phase transition, then we are part of the very first generation of the forest to reach the sun. But this also means we are the first generation to witness the true scale of the storm. The researchers found that even with conservative estimates, the astrophysical resets are a dominant force in the evolution of the galaxy. This challenges the idea of the Great Filter as a biological hurdle. The filter is a matter of catastrophic timing. We have spent decades searching for a reason why aliens do not exist, and the reason may be that they were simply born during a strike. They were the sprouts that were cleared before they could branch out. Humanity represents the only ones who found a gap in the lightning. The existential implication of the flash in the dark model is a shift in perspective. We must stop viewing the universe as a stable stage for our drama. The universe is a regulation machine that periodically clears the stage. We are the actors who have finally been given a long enough scene to speak our lines. This realization is not a cause for despair. The realization is a call to urgency. If we are a flash in the dark, then we must make the flash count. We must understand that the window of stability is not a permanent right. The window is a temporary privilege. The astrophysical regulation model suggests that the galaxy is finally waking up, but the false vacuum model suggests the galaxy is waking up in a house that is already on fire. The synthesis of these cosmic threats reveals that humanity is standing at a unique threshold in the history of the universe. We have survived a 4-billion-year gauntlet. We have navigated the thin rings of the galactic habitable zone and the lethal beams of the stars. We have emerged into a moment of galactic silence. But this silence is a synchronization, a pause before the next reset. We are the first generation of observers in the history of our galaxy capable of seeing the threats. We are the first who can begin to think about galactic mitigation. This realization brings us to the final act of our journey. We must confront the reality of our position. We are the fragile watchers of a lethal clock. We are the only ones who can decide if the story of life ends with a whimper or a transformation. The stakes have escalated from the local stars to the structure of the universe. We are standing at the edge, and the choice is ours. The universe does not care. The universe only provides a moment. We must decide if this moment is the beginning of a legacy or the final flicker of a flame that never truly mattered. The clock is turning. The reset is coming. And the choice remains with the only ones who are left to make the choice. These super resets define the hard limits of existence. To understand why we are still here, we must quantify exactly how lucky we are. To survive for 4 billion years in a galaxy designed to kill you is not normal. This survival is a statistical anomaly so extreme that the fact demands an explanation. Consider the timeline we have just walked through. For 4 billion years, the Earth has remained habitable. The oceans did not boil away. The atmosphere did not strip away. The surface was not sterilized by a nearby gamma-ray burst. This stability feels natural to us because the calm is the only history we know. But when we look at the violence of the rest of the galaxy, this stability appears less like a natural law and more like a winning lottery ticket that we have hit every single day for 4 billion years in a row. The sheer improbability of this survival was quantified by researchers like Andrew Snyder Beatty at Oxford University. In a 2018 study, his team analyzed the steps required for intelligent life to emerge. They analyzed the transition from non-life to life. They looked at the jump from simple cells to complex cells. They looked at the transition to sexual reproduction, and crucially, they looked at the time required for each step. Their conclusion was sobering. The expected time for these transitions to occur is often longer than the habitable lifetime of a star. The timing suggests that for most planets, the star dies before the civilization is born. We are the ones who beat the clock. We are the ones who ran the gauntlet of the galactic habitable zone and somehow, against all odds, reached the finish line before the lights out. To understand the mechanics of this outlier status, we must look closer at the transitions. The jump from simple cells to complex cells took 2 billion years. For half of the history of the Earth, life was nothing but slime. This era is often called the boring billion. For an immense stretch of time, the Earth was dominated by simple organisms that barely changed. The evolutionary engine was stalled. The transition to complexity required a freak accident known as endosymbiosis, where one bacterium swallowed another, but failed to digest the meal. The trapped bacterium became the mitochondria, the power plant of the complex cell. If the sun had been slightly more active, or if a nearby star had exploded during that 2 billion-year wait, the slime would have been sterilized and the clock would have reset to zero. The fact that we survived that vulnerable window suggests that we are surfing on the crest of a very unlikely wave. The mathematics of this survival are described by the hard step model, a concept originally proposed by astrophysicist Brandon Carter. Carter argued that if a process requires several difficult steps to occur within a limited time window, the steps will tend to be spaced out evenly against the deadline. This pattern is exactly what we see in the fossil record of the Earth. The major evolutionary leaps are separated by hundreds of millions of years, and the final leap to high intelligence occurred only moments before the sun begins to heat up and render the Earth uninhabitable. This timing is suspicious. If intelligent life were easy, the transition should have happened billions of years ago. This timing implies that we are the result of a series of events that are incredibly unlikely to occur in the correct order. We are not the standard outcome of planetary evolution. We are the result of winning a cosmic coin, toss 5 times in a row. Imagine walking through a minefield that stretches for 1,000 miles. You have to walk blindfolded for 4 billion years and never step on a single mine. That is what the Earth has done. The mines were the supernovae that shattered the nights of the early solar system. The mines were the asteroid impacts that cracked the crust. The mines were the solar flares that tried to strip the air. Most planets step on a mine eventually. Mars stepped on a mine when the planet lost the atmosphere. Venus stepped on a mine when the world suffered a runaway greenhouse effect. Earth kept walking. The data implies that humanity is more than a biological species. We are a statistical outlier. We are the result of a chain of survival so unlikely that we may be the only ones in the Milky Way who have ever completed the journey. This realization forces a fundamental reframe of the Fermi Paradox. For decades, we have asked why biology is so rare. We assumed that the hard part was the origin of life. We assumed that the universe was empty because the chemistry was difficult. But the astrophysical evidence suggests the chemistry is easy. Amino acids are found in comets. Organic molecules float in interstellar clouds. The universe wants to create life. The problem is that the universe also wants to destroy life. The paradox is not about the rarity of creation. The paradox is about the difficulty of retention. The great filter is not a wall that stops life from beginning. The great filter is an eraser that removes life after the story has begun. The researcher Milan Cirkovic calls this concept timescale forcing. His work suggests that the galaxy operates on a schedule. The catastrophic events we have discussed, specifically the gamma-ray bursts and the spiral arm crossings, act as global reset mechanisms. These events synchronize the clocks of every planet in the galaxy. When a major burst occurs, the radiation sterilizes an entire sector of space. The flash resets the evolutionary timer for a huge region. The synchronization means that civilizations do not emerge randomly over time. They emerge in waves, in the brief windows of silence between the resets. We are likely part of the very first wave to survive this far. The silence of the radio sky is not because we are alone in space. The silence is because we are alone in time. We are the first generation to wake up after the storm. Consider the synchronization of a forest fire. Before the fire, trees are of all different ages. But after a massive burn clears the land, every new tree starts growing at the exact same time. The galaxy is that forest. The gamma-ray bursts are the fires. We are the saplings that started growing after the last great burn. The reason we do not see older, taller trees representing galaxy-spanning civilizations is that the fire took them all. We are not late to the party. We are the first ones to arrive after the renovation. The silence of the forest is not a sign of peace. The silence is a sign of recent destruction. A healthy forest is loud, but a forest that has just burned is dead silent. The only sound is the cracking of cooling ash. The Milky Way is a forest of ash. We look out and see no Dyson spheres blocking the light of stars. We hear no radio leakage from interstellar empires. We see no fleets of von Neumann probes dismantling asteroids. This absence is the footprint of the fire. The galaxy has been burned clean of high-complexity structures. We are the first green shoots pushing up through the layer of carbon. The silence is profound because the silence is unnatural. The universe should be loud with the noise of construction. The fact that the universe is quiet tells us that the fires are frequent and the fires are total. This timing argument changes the stakes of our existence. If we were just one of millions of civilizations, our survival would not matter much to the galaxy. If we failed, someone else would succeed. But if we are the statistical outlier, if we are the only ones who have survived the gauntlet, then our failure would be a cosmic tragedy. Failure would mean that the 4 billion-year streak of luck was for nothing. The silence would mean that the only consciousness in this sector of the universe would be extinguished, and the galaxy would return to being a graveyard of simple cells and dead rock. The burden of the first mover is heavy. We are carrying the torch of intelligence through a dark room, and we do not know if anyone else is coming behind us. But this position as the first observer brings a unique capability. We are the first species in the history of Earth, and perhaps the history of the Milky Way, that can see the minds. The dinosaurs did not know the asteroid was coming. The trilobites did not know the gamma-ray burst was flaring. These creatures were passive victims of the cosmic environment. Humanity is different. We have built telescopes to watch the sky. We have built spacecraft to deflect asteroids. We have mapped the magnetic fields of the sun. We are more than biological survivors. We are the beginning of a galactic mitigation engine. Galactic mitigation is the concept that intelligence can intervene in the astrophysical processes of the universe. We are already doing this on a small scale, altering the orbits of asteroids and hardening our power grids. But the potential goes far beyond planetary defense. Theoretical physicists have proposed concepts like the Shkadov thruster. The Shkadov thruster is a stellar engine, a megastructure designed to move an entire star system through the galaxy. The design is elegantly simple. We would construct a massive hemispherical mirror, perhaps made of aluminum foil as thin as a sheet of paper, but spanning millions of miles. This mirror would hover over one pole of the sun, held in place by the balance between the pull of gravity and the outward pressure of sunlight. The construction of such a mirror requires engineering that borders on magic. We might have to disassemble the planet Mercury to get the raw material, processing the rock into ultra-thin sheets of reflective foil spanning millions of miles. These sheets would be stitched together to form a massive arc hovering over the pole of the sun. The project would take centuries, but the result would be a cockpit for the solar system. By reflecting a portion of the light of the sun back onto the star, we create thrust. The sun is pushed by the pressure of the reflected photons. The sun drags the planets through gravity, so moving the sun moves the Earth. The acceleration would be incredibly slow, taking millions of years to change the velocity of the solar system by a significant amount. But in the time frame of the galaxy, This engine changes everything. We could steer our entire solar system out of the path of a supernova. We could navigate away from a dangerous spiral arm. We could drive our planet out of the danger zone and into a safe harbor. We would no longer be passengers on a bus with no driver. We would be the captains of our own star. Living in a system powered by a shut-off thruster would be a surreal experience. From the Earth, the mirror would appear as a vast, shimmering arc in the sky, brighter than the full moon, reflecting the sun back at us. This structure would be a constant reminder that we are no longer drifting, we are driving. This capability is what separates a Type 1 civilization from a Type 2. A Type 2 civilization does more than inhabit a star system. That civilization drives the star like a ship. We are the immune system of the universe, evolving to protect the complexity of life from the violence of physics. The concept of mitigation represents the ultimate answer to the Fermi Paradox through the lens of cosmic threats. The reason we see no aliens is that no one else has reached the mitigation stage. The universe is a lethal machine that naturally grinds civilizations down before they can control their environment. We are the first ones to reach the control panel. We are the first ones who have a chance to stop the machine from resetting. The psychological shift required for this transition is the final filter. A species that evolves in a high-threat universe is naturally paranoid. We are evolved to react to immediate dangers, a tiger in the grass, a famine in the winter, a war with a neighboring tribe. Our brains are not wired to think in timelines of millions of years. We struggle to plan for the next election cycle, let alone the next galactic orbit. But galactic mitigation requires a species to think like a planet. We must be willing to start projects that our great-grandchildren will not see finished. We must be willing to invest energy in threats that will not arrive for 10,000 years. This requirement is the true test of intelligence. Can a biological organism overcome the short-term programming of evolution to solve a long-term astrophysical problem? This synchronization is why the silence is so profound. The quiet is the silence of a waiting room. The universe is waiting to see if the first intelligence can actually survive the transition from passive observer to active protector. The scope of this responsibility is absolute. We cannot afford to be distracted by petty conflicts or short-term thinking. The threats we face are not political. The threats are astrophysical. The scale is measured in galactic rotations. If we allow ourselves to be wiped out by a random rock or a solar flare, we have failed the test of intelligence. We have squandered the statistical miracle of our existence. The universe has given us a head start. We are standing at the edge of the cosmic ocean, watching the waves crash against the shore. We know that a tsunami is coming. We know that the ground is unstable, but we also know how to build a boat. We know how to build a wall. We have the plans to move to higher ground. The difference between us and the dead worlds of the past is that we have a choice. We can close our eyes and hope the luck holds, or we can open our eyes and start building. This step separates a fleeting flash in the dark from a civilization that can endure the night. The universe does not negotiate. Physics does not care about art, love, or philosophy. A gamma-ray burst will strip the atmosphere of a planet of poets just as easily as the radiation strips a planet of bacteria. The only force that can stop a cosmic threat is a cosmic solution, and the only entity that can build a cosmic solution is a technological civilization that understands the scale of the problem. We are that civilization. We are the only ones who can do the work, and we are running out of time. The narrative brings us to the final realization. The Fermi Paradox is not a mystery to be solved. The Fermi Paradox is a challenge to be met. The silence of the universe is not a sign of despair. The silence is a sign of opportunity. The stage is empty. The lights are on. And for the first time in 13.8 billion years, an actor has walked out from the wings who knows the lines. We are the fragile watchers of a lethal clock, but we are also the hands that can stop the hands from turning. The question is no longer where is everybody. The question is where are we going? And the answer depends on whether we are willing to face the reality of our position. The gauntlet is not over. The minefield remains. But for the first time, we have a map. The map we have drawn is not a chart of safe harbors. The map is a record of shipwrecks. We have looked at the history of the Milky Way and seen a galaxy that is hostile to complex life. We have seen that the silence of the radio sky is not a paradox, but a prediction. The universe is not a garden waiting to be explored. The universe is a machine that grinds civilizations into dust before they can learn to speak. The fact that we are standing here, holding the map, is the single most important data point we have. Consider the silence again. When we started this journey, the great silence felt like a haunting. The void felt like a sign that we were missing something. But now, the silence looks different. The silence looks like a clearing in a forest after a fire. For billions of years, the gamma-ray bursts burned down every complex structure that tried to rise. For billions of years, the supernovae sterilized the spiral arms. The galaxy was a place of violence and resets. But recently, the fires have died down. The bursts have become less frequent. The heavy elements have settled into the disk. The clearing has opened up. And in that clearing, we are the first green shoot to push through the ash. The silence is not a sign of emptiness. The silence is a sign that we are the first to arrive. To understand why this clearing exists, we must look at the metabolism of the galaxy. For the first 10 billion years, the Milky Way was a chaotic construction site. Gas clouds collapsed at furious rates. Massive stars burned through their fuel in mere millions of years, detonating as supernovae that flooded the disk with radiation. The core of the galaxy was an active volcano of high-energy particles. In that environment, a planet like Earth would have been sterilized before the first bacteria could learn to use sunlight. The chemistry of life requires stability, and stability was the one thing the early universe could not provide. But galaxies, like organisms, mature. The star formation rate has slowed down. The chaotic mergers have stopped. The active galactic nucleus has gone to sleep. The dangerous giants that explode as gamma-ray bursts are becoming rarer, replaced by the steady, long-burning stars that can host stable solar systems. We have emerged at the specific moment in cosmic history when the violence has subsided just enough to allow the fragile chemistry of intelligence to hold together. We are the children of the galactic quiet. This realization forces a total re-evaluation of the human story. We often tell ourselves that we are insignificant. We look at the scale of the universe, with the trillions of stars and the billions of years, and we feel small. We feel like a biological accident on a rock that does not matter. But the astrophysical evidence suggests the exact opposite. If the universe is a regulation machine that destroys 99% of what the cosmos creates, then the 1% that survives is not insignificant. The survivor is the most important part of the system. The fact that we have survived the filter of the gamma-ray bursts, and the filter of the unstable orbits, and the filter of the vacuum decay means that we are rare. And in a universe made of dead matter, rarity is the only currency that has value. We are not just observers of the cosmos. We are the survivors of a 4 billion-year war of attrition. Every cell in your body carries the legacy of that survival. The iron in your blood comes from stars that exploded but did not kill your ancestors. The water in your cells comes from comets that bombarded the Earth but did not sterilize the oceans. Your DNA is a record of near misses. We are the descendants of the lucky ones. But luck is not a strategy. Luck is a wasting asset. The universe has given us a window of stability, but the universe has not given us a guarantee. The window will close. The next burst will fire. The next asteroid will fall. The difference is that this time, the universe has produced a mechanism that can see the threat coming. This moment represents the pivot point. Here, the story changes from a tragedy to an opportunity. For 13.8 billion years, the universe was blind. Stars formed and died in the dark. Galaxies collided without anyone to watch. Black holes evaporated in silence. Gravity and entropy ran the clock without witness. But then, on this one wet rock, the universe woke up. Matter organized into complexity. Complexity organized into intelligence. And intelligence built eyes to look back at the stars. We are the universe becoming conscious. We are the mechanism by which the cosmos understands the existence of reality. This consciousness brings a terrifying responsibility. If we are indeed the only ones in this sector of the galaxy, or perhaps the only ones in this observable volume of space, then we are carrying a very heavy flame. If we extinguish ourselves through nuclear fire, or ecological collapse, or artificial stupidity, we are not just killing a species of primate. We are blinding the galaxy. We are turning the lights off in the only room that has someone home. If we die, the cosmos returns to being a machine. Reality returns to the blind cycles of fusion and collapse. The art, the music, the science, the love, the meaning that we have generated would vanish, and no one would remain to remember that meaning ever existed. The silence would return, and this time, the silence might be permanent. Consider the alternative. If we fail, the Earth will continue to spin, the bacteria will continue to replicate, the oceans will continue to rise and fall. But without intelligence, the Earth is just another rock waiting for the next reset. No one will exist to deflect the asteroid that arrives in 10 million years. No one will remain to move the planet when the sun begins to expand. The biological experiment that began 4 billion years ago will end in fire, just like all the others. But if we succeed, if we survive the next few critical centuries, we open the door to a future that is functionally infinite. We are not just protecting the 8 billion people alive today. We are protecting the trillions of potential humans who could live in the future. We are protecting the music that has not been written, the science that has not been discovered, the civilizations that have not yet been built. The stakes are not just about the present. The stakes extend to the entire potential of the future light cone of Earth. This perspective changes how we view our current problems. We spend our days worried about the next election, or the stock market, or the border disputes of nations. These problems feel huge because we are standing inside them. But from the perspective of the galactic habitable zone, these problems are noise. The galaxy does not care which political party controls the Senate. The galaxy cares about whether we can deflect an asteroid. The galaxy cares about whether we can become a multi-planetary civilization before the next supervolcano erupts. The galaxy cares about whether we can master the physics of energy before we burn up our biosphere. We are arguing over cabin assignments on a ship that is sailing through a minefield. The architect perspective demands that we look up from the petty squabbles of the deck and look out at the horizon. The transition we must make is the transition from passenger to pilot. A passenger assumes that the vehicle is safe. A passenger assumes that someone else is driving. A passenger complains about the food and the service. But a pilot checks the engines. A pilot watches the radar. A pilot understands that the safety of the ship is their personal responsibility. Humanity has been a passenger for 200,000 years. We have ridden the Earth through the easy years of the Holocene, but the ride is getting bumpy. The engine light is blinking. The time has come to walk into the cockpit and take the stick. This concept of galactic mitigation that we touched on earlier is not science fiction. This technology represents the graduation requirement for a technological civilization. A species that cannot control the host star is a species that is doomed to die with the host star. A species that cannot navigate the galaxy is a species that is trapped in a burning building. The Shatov thruster, the Dyson swarm, the star lifting, these are not dreams of conquest. These are safety features. We build them not because we want to rule the galaxy, but because we want to survive the galaxy. We build them because we understand that the default state of the universe is dead silence, and we prefer the noise of life. Building these systems will require a psychological shift that is even harder than the engineering. We are evolved to think in seasons, not eons. Our brains are wired to worry about the tiger in the grass, not the supernova in the spiral arm. To build a Shatov thruster requires a project that spans thousands of generations. The project requires planting trees under whose shade we will never sit. The project requires a civilization that values the survival of descendants as much as personal comfort. This challenge is the great filter that lies ahead of us. The barrier is not a filter of physics. The challenge is a filter of will. Can a biological organism overcome short-term programming to solve a long-term cosmological problem? The silence of the universe suggests that most cannot. The silence suggests that most civilizations burn out before they can build the lifeboats. We have to be the exception. The skeptics will say that this is arrogance. They will say that we are too small to change the heavens. They will say that we should accept our place as a part of nature, not the master of nature. But this humility is misplaced. Nature is not a benevolent mother. Nature is a disinterested process. Nature is the asteroid that killed the dinosaurs. Nature is the gamma-ray burst that sterilizes the world. To accept the default path of nature is to accept extinction. The act of civilization is the act of defying nature. We build roofs to defy the rain. We build medicine to defy the disease. We build agriculture to defy the famine. Galactic mitigation is simply the logical extension of building a roof. We are building a roof over our entire world to protect the world from the storm of the cosmos. We are the only entity in the known universe that cares about the future. The sun does not care if the star burns out. The asteroid does not care if the rock hits us. The vacuum does not care if we freeze. We care. That capacity to care, to value existence, to prefer life over death, is the most precious attribute in the universe. This capacity is the spark that lights the dark room. And we must protect this spark with the ferocity of a mother protecting a child. We must protect this spark from the external threats of the cosmos. And we must protect this spark from the internal threats of our own nature. The Fermi Paradox is often framed as a question of location. Where are the aliens? Are they behind that star? Are they in that nebula? But the paradox is really a question of time. The question is not where they are. The question is when they are. And the answer seems to be that they are not yet. We are the early risers. We are the morning shift. The galaxy is opening up for business, and we are the first ones to unlock the door. The isolation means that no one is coming to save us. No galactic federation exists to intervene if we make a mistake. No wise elders exist to guide us through the adolescence of nuclear power. We are on our own. This solitude is frightening, but the isolation is also clarifying. Solitude removes the illusion of a safety net. Isolation forces the species to grow up. If we want a universe full of life, we have to build the universe. If we want a galaxy that is safe for consciousness, we have to secure the galaxy. If we want to meet other civilizations, we may have to wait for our own children to spread to the stars and become them. We are the seed from which the galactic civilization will grow. The silence is not a void to be feared. The silence is a canvas waiting to be painted. So, look up at the night sky tonight. Do not look for the ships of conquerors. Do not look for the signals of friends. Look at the stars as a wilderness that has not yet been tamed. Look at the darkness as a challenge that has not yet been met. We are the fragile watchers of a lethal clock. The hands are ticking. The mechanism is grinding. The reset is coming, but we are not helpless. We have the tools. We have the map. We have the mind. The only variable left is the will. The universe does not care if we survive. The universe does not care if we die. The universe just is. But we care. And because we care, we can change the outcome. We can grab the hands of the clock and hold them back. We can build a shield against the dark. We can turn this brief flash of consciousness into an eternal flame. The silence of the galaxy asks us a question. The silence asks if we have the courage to be the first. The answer will not be written in the stars. The answer will be written by us. The clock is ticking, and the choice is ours. What we have just uncovered is not just a fact about Fermi Paradox solutions through cosmic threats. The discovery is evidence that our intuitions about alien life being common are completely wrong. The universe operates on rules that feel alien to our human experience. The gap between what we thought and what is actually true is where science thrives. I hope you found some value in the deep dive of today. If you did, and you want to support the research that goes into these videos, a donation link is in the description. Your support makes a huge difference and allows me to keep digging deeper. If you know someone who is obsessed with Fermi Paradox solutions through cosmic threats, send this video their way. This action is the best way to help this community grow and reach more curious minds. I will catch you in the next one. Let curiosity guide you. Keep learning and know that you are always appreciated.